Hello, everyone, and welcome to our webinar today. My name is Nate Hausman. I'm a project director at the Clean Energy States Alliance, and I'll be your host for today's webinar. So our topic for today is solar photovoltaic recycling, issues and considerations for state decision makers. We've got a great guest speaker on the line with us today, Garvin Heath from the National Renewable Energy Lab, or NREL. And before I pass it over to Garvin for his presentation, I just want to go over a few quick housekeeping notes. All of our attendees for the webinar today are in listen-only mode. You have a couple of options to join the audio portion of the webinar. You can connect using your computer audio, or you can call in via a telephone landline. If you'd like to minimize the webinar console, you can view the presentation full screen. Just click the orange arrow that you can see circled on this slide. You can also click this button again to expand the webinar console. A very important note, we ask that you send in your questions by typing them into the question box on the webinar console and hitting send. We'll save about 15 minutes at the end of the webinar for a Q&A with you, and we want to get as many questions in the queue as we can as we go. So we've got a lot of people registered for today's webinar, which should mean a lot of questions. And so to make sure we get to your question, type it in as you think of it, and don't wait till the end to submit your question. Finally, I want to note that this webinar is being recorded. We'll post the webinar slides and a recording to the webinar on our website, and we'll also be sending you a follow-up email with a link to the webinar materials. The recording should be ready within 24 hours or so, most likely tomorrow afternoon. So with that, let me just give you a little bit of background on the Clean Energy States Alliance, or CESA. CESA is hosting today's webinar, and the Clean Energy States Alliance is, we're a national nonprofit network of public agencies and organizations working together to advance clean energy. We're mostly made up of agencies at the state level, and on this slide you can see all our members. Today's webinar is being conducted through the National Renewable Energy Lab Solar Technical Assistance Team, or STAT network. The STAT network provides unbiased technical assistance on solar policy and issues for state and local governments and decision makers. This particular webinar grew out of a STAT technical assistance request related to PV recycling. And NREL has partnered with CESA and the National Association of State Energy Officials, or NASEO, on the outreach and delivery of its solar technical assistance under the program. The program is funded through the U.S. Department of Energy Solar Energy Technologies Office. The program, the STAT network, is sunsetting next month, but NREL has other technical assistance opportunities available. You can find out more about the STAT program and NREL's other ongoing technical assistance opportunities at the URL at the bottom of the screen. Okay, well, with that, let's get to today's content. I'm going to introduce our speaker for today, and then I'll turn it over to him to discuss solar PV recycling. So Garvin Heath is a senior scientist and leader of sustainability analysis at NREL. For the last 6 years, he has led the International Energy Agency's Photovoltaic Power Systems Task 12 Sustainability, where the U.S. has gained valuable insight and lessons from countries with more experience in the recycling of PV modules. Garvin now leads the development of a PV recycling technology R&D roadmap for the U.S. Department of Energy. He has helped develop a new voluntary sustainability leadership standard for PV module manufacturing, including end-of-life management, and has helped the state of Washington develop implementing regulations for their first-in-the-nation PV recycling mandate. All right, with that, Garvin, I'll turn it over to you. I'm going to pass you screen control now, and I'll let you take it away.
Wonderful. And you can hear me still?
I can hear you loud and clear.
Great. Okay, wonderful. Well, thanks so much for the opportunity. I'm really pleased to be able to talk to who I assume are a lot of stakeholders at the state level. And I understand that there are many states that are considering now what to do, or to get ahead of what to do with PV modules that are being installed at a great rate in almost every state in the country. And this presents some challenges, but also opportunities, I think, for the U.S. manufacturing sector, for employment, and also for the recovery of critical, as well as the recovery of critical materials, as well as ensuring that toxic materials don't get released to the environment. So this work is, there's a brief disclaimer. I won't go over this. You'll see it in the slides when you want to do this, when you want to review later. So the outline is that I want to review first really the motivation and need for recycling of photovoltaic modules, then transitioning into what kind of value we can create from recovering materials from PV modules, as well as for development of the manufacturing sector. There are also some challenges to recycling, some of which I'll highlight. Potential synergistic trends that can enhance the ability going forward to recycle these modules. Some relevant international research, and that comes from this International Energy Agency, or IEA, group that I lead. And then finally, some information gaps that can help develop a robust PV recycling industry that states, I think, can have a role in helping to fill. So this is a projection developed in a report that was a partnership between the group that I lead from IEA and another international organization called IRENA, the International Renewable Energy Agency, where we looked at the deployment going forward out to 2050 of PV modules. And based on information that was available at the time, this was published in the year 2016, we then projected forward when we would expect end-of-life modules to, or when modules reach the end of life and then become a waste management challenge. And so this chart shows the cumulative PV panel waste in millions of metric tons. And following the lifetime of a PV module, which is typically assumed to be between 25 and 35 years, also considering some early losses to those modules from either transportation or some early failures and things. It's not at a high rate, but it does contribute to waste. Then the projection goes out with this sort of very steep increase from where we are today in 2016, starting on that increase of 2030, and then finally reaching some pretty high volumes by 2050. And just to put this in context, this compares to global e-waste. So now this is all electronics, but really excluding PV because of the incredibly minor contributor at the year of this particular figure, about 42 million metric tons in 2014. So the annual PV waste now is about 1,000 times less than this, but in 2050, it could exceed 10% of that record annual volume of global e-waste. And that's that would make it a sizable contributor to e-waste, which probably many of you know has been a challenge identified a couple decades ago, but that we're still trying to address today. And it's not just in other countries, but it's actually here in the US where we're going to have a lot of, expected by 2050, a lot of PV waste. In fact, the US is predicted by our own estimates to be the second largest in the world of PV waste volume. And this presents both challenges and opportunities. Just to give you a sense, perhaps a colorful sort of illustrative sense that I received from Sam Vanderhoof, who is the CEO of recyclepv.solar. That's a URL that you can go to. There are approximately 7 million pounds of solar panels being installed in the US every single day. That's a very large number. The US has installed about 53 gigawatts cumulatively to date of PV modules, and that equates to about 175 million solar modules. These are using some very kind of back of the envelope assumptions and rules of thumb, but I think it gives you kind of a picture about how many modules we're talking about. If we were to put 53 gigawatts, the cumulative capacity installed today, and stacks them together into shipping containers, put those shipping containers end to end, loaded them onto a train. That train would be more than 2,000 miles long. That nearly stretches across the whole continental United States. So there's a lot of modules that we have today. Now, they're not all expected to become waste anytime soon because most have been deployed only recently, but there is an expected sort of curve, and we'd like to learn more about that, of waste predicted in the future. And the US, as we see here in the global context, has the second largest amount. So why should we recycle these modules? Well, there's valuable materials recovered that can be recovered in them, and we can also prevent the release of toxic materials. And so we did an estimate in the same IEA ARENA report of a technical potential that is not, this would not necessarily be achievable. This is just looking at, what's available, and if we had 100% recovery of this, of the amount of materials that we could recover from these PV modules. And of course, glass is sort of the leading by mass, but polymers and then aluminum, that's the aluminum frame. Silicon, of course, is the basic material, photoelectric material that's used for most of the modules that are deployed today. And then on down the line to some obviously valuable materials like copper and silver at the bottom, but also some toxic materials like lead you can see in the other metals category. And this is by 2030, these estimates. And sort of put in a different way, the relative value contained in a crystalline silicon CSI panel, based on compositions that were reported some years ago, but still quite relevant. Silver is nearly half of that value, even though it's a very, very, very small fraction of the total mass. It's a valuable, quite a valuable material, and so that mass means that it has a lot of value. There's a lot of potential for value creation, and this could incentivize or could provide for the development of a whole new waste management industry, perhaps, one specialized in PV. By 2030, where the cumulative PV capacity is expected to be about 1,600 gigawatts, that's about somewhere between 2 and 8 million tons of cumulative PV panel waste by that time. But in value, that's about $450 million US cumulatively. And just for the US, this is the global context, just for the US, that's about $60 million by 2030. If we were, in a circular economy perspective, be able to recover those materials, put them back into panel production, we could produce about 60 million new panels, or equivalent to 18 gigawatts from those recovered materials. By 2050, the numbers go up considerably. And if you reflect back on the second slide that I had, where that curve really bends sharply upward by 2050, now we're talking about 15 billion US dollars globally that could, from the value of these recovered materials, and about $2 billion for the US alone, and then enough raw materials to produce about 2 billion new panels. Now, these are again based on technical potentials. We probably in real life wouldn't quite be able to achieve this, but this is sort of the presentation of the opportunity for the value creation. Extending the value chain from where we are today to where we would need to be is really an important consideration, and it would require cooperation amongst new partners to create what would hopefully be a vibrant industry. R&D organizations, of course, are going to be important for this because we really still have to develop highly effective, cost-effective technologies to recover these materials. There will need to be developed not just a recycling industry, but also repair and reuse, so that we can make the highest value choices for how to deal with the end-of-life management challenge for these modules. And then a recycling and treatment industry that can address what is a product that is quite different in some ways from any previous product that's been treated, especially in large scale in the past. And so this optimal PV recycling industry will integrate some features as well as actors from both the energy and waste sectors. Some of the challenges that we see going forward, first, thinking about waste management and recycling, is that to prepare technologies, systems, and policies to manage decommissioning of systems when they reach the end of life, and then disposal at the end of life, we want to try to simultaneously and optimally achieve multiple goals. We want to minimize costs, of course. We also want to minimize environmental impacts while maximizing material recovery. And there's also a front end to this process. So we shouldn't forget that the PV modules, they're designed for 30 years or more of outdoor field use in some often pretty extreme and harsh environmental conditions. That means that they're incredibly durable, which is almost antithetical to the easy recovery then of materials from those modules at the end of life. But I say almost because if we're smart about it, we can actually design these modules for more ease and recyclability, increasing the speed and the ease of dismantling, improving the rate and also the purity of recovered materials, as well as reducing waste. So we need to address end of life at some point, and we already have systems in place and more being installed today before we would get ahead of things in design for recycling. But we shouldn't forget that there's a front end of this, that we can try to manage this problem better from the front. There's also another challenge to this value proposition, which is dematerialization. So to remind us again where the value of the modules is in the silver, which is a very, very small mass fraction, that's also a high cost item for manufacturing these modules. And the manufacturers themselves are quite interested in trying to reduce the silver content in their modules because that can help to manage and lower their costs for their manufactured product. And so we can see the bottom figure showing a projection, really a roadmap of the expected silver consumption per watt peak, WP. And it's a pretty significant decrease in silver, which then makes recycling a bit more challenged from the value perspective because you have less and less silver to recover from each of those modules. Another potential opportunity, and I'd say this is a synergy that we have, is not only growing end-of-life waste, but also a growing manufacturing sector in the U.S. This is a picture that NREL has compiled of the photovoltaic value chain, including both components and then cell or module manufacturing in the U.S. and where it's located in the approximate size of these manufacturing facilities. It's spread out amongst many states in the U.S. Not all, of course, but many states have capacity in this, and it's expected to grow. The next slide shows this. This is just the announcements of increased or expansions for photovoltaic component manufacturing in the U.S. Some of this is probably due to the tariff being imposed, and one way to get out from under the tariff is to build the capacity in the U.S. because the tariff applies only to imported photovoltaics. So there's been a lot of, I would say, a significant amount of announced manufacturing capacity expansion. And this then leads to an opportunity where off-spec manufactured products can be one source, and I would say from this picture an increasing source of materials that would go into the recycling industry, especially at the early stage. And because PV modules have this typical 30-year lifetime, it takes a long time from deployment to when they become waste. That's a challenge then for the recycling industry to start now. The manufacturing sector and the off-spec product that comes off of that could be one source in the near term of increased volume for PV waste to then to develop a recycling industry around. Is there perhaps also some market pull for recycling? I offer as one example of this something that I was involved with and that perhaps for other reasons your energy agencies might be interested in. It's referred to as the NSF 457. And NSF is just an organization, the acronym for that organization, that developed under ANSI standards, the American National Standards Institute guidelines, a new standard, the Sustainability Leadership Standard for PV module manufacturing. It was published at the end of last year, so it's been available for, I guess, 9 or so months now. And what it was intended to do was be a comprehensive framework to establish product sustainability performance criteria, as well as corporate performance metrics that exemplify leadership in sustainability, including third-party verification. And what it aims to do by identifying specific modules that can be certified to the standard is to enable easier specification for purchasing of high sustainability performance modules under large purchase contracts. So it alleviates then individual purchasers from the challenging task of defining for themselves sustainability performance of PV modules where they may not have that expertise. There is potential that this standard would be adopted by an organization called the Green Electronics Council, which runs probably a familiar registry to many of you, the EPEAT registry, which has been quite successful in the past of identifying those sustainability leaders in especially the IT space. So monitors and cell phones and servers and other things are all in this EPEAT registry, or soon will be. And the PV modules could be a new category in that. There'll be 3 tiers of performance: bronze, silver, and gold. And it's not meant to tier everyone in the marketplace to these levels, but only really identify those that are the leaders. And that can then be a market pull because, as you'll see in the next slide, one of the sustainability performance categories that's included in the scope of this standard is responsible end-of-life management, which provides a way for manufacturers in developing recycling programs for their products to, in essence, get credit for that, and then to achieve high sustainability performance certified at the standard, and then improve hopefully their market share by being in the EPEAT registry and getting large purchasers interested in buying their products. Switching now to some of the international work that I've been had a pleasure of working with collaborators from many different countries in producing. Some of these results I think may be interesting and I think are also relevant in the US. They're not so specific to other countries that they aren't relevant here. One report that we published very early in this calendar year was regarding the energy use and material flows for current PV module recycling processes in Europe. In Europe right now, there's a requirement for PV modules, or rather for manufacturers that put on the market PV modules from wherever they're manufactured, whether in Europe or outside of Europe. Once they enter Europe, they have to pay into a fund under these WEEE regulations that require module recycling at end of life. And yet few environmental assessments have been published about these kind of recycling technologies, and in particular the current ones, the ones that are used today. So we did a survey of current recyclers in Europe. There are not that many, but we sent out 9 surveys, and 5 of which were returned with information about their process, as well as the energy use and material recovery from that process. So you can see the different recyclers that responded to the survey. 3 of them were existing glass recyclers that are putting PV modules through in a batch. So they're sort of collecting them up, they're putting them in a warehouse on the side. As soon as they have a large enough quantity, they shut their machines down, recalibrate them somewhat, put PV modules through, and then once they're through, they go back to their normal glass processing. There's a metal manufacturer that's a very similar circumstance, using a batch process for PV modules. And then finally, there was built in Italy one that was a prototype system built at a pilot scale that was specifically engineered towards PV and exclusively PV, but it's not operational now due to lack of enough quantity of modules to run through to make the system economic. So we mapped out in this report the process flow. That's the left diagram is an example of that. At kind of a high level for what they're doing. We collected information about the electricity use per ton of the module input, as well as then the material recovery rate. And that's the lower figure on the right, where there's a reasonable amount of variability in the total mass fraction that's recovered of all the mass that's put in the module at the front end, from this respondent number 1 of around 75% to the pilot system that was really engineered towards PV modules, which was a little more than 90% of material recovery. So there's some variability there, and information then that's useful perhaps for thinking about designing new systems, especially in the U.S. where they largely have not been designed yet. Another project that resulted in a report, again published early in this year, was looking at trends in the development of recycling technologies for PV modules. This followed from that first report, the IEA ARENA report that I've already shown you some figures and results from, where we wanted to get a little bit deeper into the technology and understand what technologies are being investigated, both from the perspective of patents, mainly patents that have been listed from companies, so private sector organizations, and thus private sector research and development, but of course also some research institutions, including academia as well as labs. And then the other perspective we took this from was from sort of country level technology R&D programs. And so specific investments that were being made by countries, for instance, Japan or Korea or China, the EU, for specific projects, R&D projects. And so we sort of tried to synthesize all of this information. We initially identified potentially about 6,500 patents, but after screening, only around 180 were actually relevant and in particular related to PV recycling. And much of them were focused on crystalline silicon, but some on thin film PV technologies. And so we then characterized what methods were being investigated using a certain classification scheme of mechanical, chemical, thermal, optical, or some combination of those. And a fair number were combination ones, especially for the thin film ones. And then sort of trying to frame all these different approaches and how they're related to each other and what methods are used, where one of the key steps that we identified to both crystalline silicon and thin film is the delamination, or how do you take apart what's been put together for a 30-year outdoor field use lifetime? How do you take that apart and then expose some of the valuable as well as some of the toxic materials that can then be more easily, enable the recovery of that after that delamination step? So you can find more information from the report that we published on this one. And then finally, we also conducted an environmental assessment using a field that our group has, many of us are experts in, including myself, called life cycle assessment. So we looked at the current treatment of the crystalline silicon PV modules and based that on the inventory that we established from the previous report that I talked about from these current systems that are deployed in Europe. And then also from published material from First Solar, which is a major cadmium telluride or thin film module manufacturer. They have published actually life cycle assessment information on their module recycling process. And so in using those and putting them into the methods of life cycle assessment, the results that we achieved at the end, in summary, as shown on this slide, are that current generation recycling, both for crystalline silicon as well as cadmium telluride PV modules, causes a very small share of total environmental impacts when these systems are deployed as residential rooftop. But I think the result would be robust if we were to look at commercial scale systems or utility scale systems for that matter. And that the net environmental impacts to benefits are primarily from the recovery of these resources. So for the sort of primary supply of these resources, but also have some benefits for other environmental impact categories such as greenhouse gas emissions or embodied energy and such. So there's more information that you can find in the report on this environmental impacts of recycling technologies. And then finally, coming to the last slide here, where I make some suggestions, and this I hope will be fodder for discussion, make some suggestions on where states in particular could help to fill some information gaps that I think are important to address. And one is, or the first maybe starts with the market size. How much PV module waste is being generated? It's a question that we don't know the answer to. The Solar Energy Industry Association, SEIA, has developed a recycling program that its members can access. And one of the features of that program is that to use the recycling network that this program has developed, you have to report back to SEIA how much waste is being recycled, how much is being sent to the recycling system, and how much materials are being recovered. Not everyone who needs to recycle modules will be a SEIA member, and the program has really just started. And so we really don't have a good sense for the full market size, which of course then can inhibit the ability of industry to feel confident in making investments to then create the recycling infrastructure that will ultimately be needed. So there's at least 3 different kinds or sources of waste. One that I talked about earlier was off-specification manufactured modules. So that's from the factory being identified as outside of their specification, and then sort of immediately enters the waste stream if it's not sold into some sort of secondary market. There are some sort of early loss failures that could be warranty issues. So if a warranty extends for 25 or 30 years for a particular module that's purchased, if the efficiency or yield from those modules is lower than the warranty level, then it might be that module needs to be taken back and the manufacturer be responsible at that point. And there's another end-of-life management choice. But there are other failures too that occur that are not of the first 2 variety, and really are then the purchaser of these modules or the owner of those modules that probably is responsible for these, which is breakage that occurs during transport or installation, but also breakage that occurs during field operation, for instance, from extreme weather. And at least anecdotally, there are many cases of that occurring in many different states across the U.S., North Carolina and Texas and New York and California, where now you have potentially a very large quantity, perhaps even the whole field for a utility deployed system, where there's a lot of waste being generated all at once, and now we got to figure out what to do with this waste. A second point of, I think, information gap is that currently the cost to recycle is high, especially relative to landfilling or other options. In some states, landfilling is illegal. In others, it is still legal. It could be PV panels could be classified as hazardous waste in some places and not in others. And so the handling of this and ultimate fate could depend on that classification. But the costs for recycling are still relatively high. And so research and development as well as industrial experience is needed to reduce the cost, also then to increase material recovery rates, increase the purity of those recovered materials so they can achieve the highest value in the resale market, and related to that, to decrease contamination. And states, especially states that are already feeling like they have a waste management challenge, perhaps from these other failure modes occurring from modules, could have some incentive then to invest in research and development to try to gain some more information and help to reduce these costs or support their industry in doing so. Finally, another suggestion for consideration is that I'm not aware of robust analysis around the design options for what a recycling program mandated perhaps by a policy decision at the state level would be, and the cost of that, both for owner as well as the administrator of the program, the owner of the modules and the administrator of the program. But in addition, how design options could affect recovery rates, compliance rates, environmental benefits, et cetera. And here we're talking not just about the recovery technologies and the recovery system itself, but in addition to that, the collection system that needs to occur at the front end, the transportation and manifesting, probably some interim storage, perhaps transfer of ownership, finally to treatment and then and then disposal. And even when high material fraction recovery is achieved through recycling, there's still going to be disposal of some of the components. And so that needs to be considered holistically as well in this program design. And there's also concerns in how these policies can be designed with regard to how current codes, standards, and other regulations might limit or present some challenge for how one can deal with PV modules at the end of life. So limiting some of the options perhaps in some locations, jurisdictions, because of these code standards and regulations that apply. And I can turn it back to the next slide, but I wanted to give both my email as well as a URL for where you can go to learn more about this international group that I lead. You can access some of the reports there that I mentioned, and that's iea-pvps.org. You can sort of forget the rest, and you can probably find Task 12. But if you do jot this down, you can get directly to the Task 12 portion of the website, and we have recent publications that are listed there, as well as information about who the international network of members are. So I want to thank those co-authors that I've worked with on the reports that I highlighted in the slides, some of the slides that you saw, as well as my colleagues at the National Renewable Energy Laboratory for this work, and for the state of Washington, which chose to use us as someone who could help provide some information to help them design their first in the nation recycling mandate, which they're going through the development of those implementing regulations right now. So with those acknowledgements, hopefully we can open it up for some discussion that I'd be pleased to engage with you on.
Great, thanks so much, Garvin. That was super interesting, and it has generated a lot of questions. So I'll just get started, and we'll get to as many of them as we can. One question is, you just mentioned how the state of Washington spurred some of this. Can you tell us a little bit more about the legislative mandate there and what the state is doing?
I can tell you a little bit about it. I wonder if a representative from the state of Washington is on, and might be better at handling that question than myself. Do we have any way of knowing that?
I can't see who might be from the state of Washington. So I can't easily unmute individual people. So
Okay.
maybe just
Okay.
at a high level,
Okay.
what the mandate is about.
Sure. So there was a mandate that was passed last year. It came through legislation, and it stated that in a future year, there could be no sale of PV modules into the state of Washington unless that manufacturer either provided offered recycling services within the state, or joined a program that provided those services in the state. And so that's a pretty significant mandate that requires anyone who wants to participate in the market in the state of Washington, will have to develop or join a program in that state. And a plan has to be put forward for how that would be achieved. And that plan would be reviewed by the Department of Ecology, who's still in the process of writing that implementing regulations. In fact, I think next week is another stakeholder meeting on that. And so, it's really just in the process of writing those regulations. So probably premature to talk about what they will specifically specify. But, that's what I think overall, that's what the mandate says.
Great, thanks. We've got a number of questions about speaking to whether or not PV panels are categorized as hazardous waste and corresponding handling and transportation requirements. And specifically, I wonder if you could speak both to, apparently there's California legislation which designates PV modules as a waste, and also what the implications are under the Federal Resource Conservation and Recovery Act, RCRA.
So I'm going to largely have to dodge that question because I am not a waste management expert, especially on the regulations, both at federal and of course the diversity of regulations that exist at the state level. It is one of those challenges that needs to be addressed by, I think, many states in order for PV to be allowed to be recycled. So for instance, in California today, there is a process that they're going through to certify PV modules as universal waste, which would then allow them to be appropriately sort of transported or handled, transported, including transported out of state, but also in state and recycled, where now they're classified as a hazardous waste without some of that flexibility. It's a process that I think needs to be handled between states and EPA federally. So it's a cooperative federalism. And as far as I understand, this is something that needs to be initiated by the states. But I don't want to speak too much more about it because I'm really not an expert there.
Great, thanks. A question about whether you're aware of any significant manufacturer, PV manufacturer designing specifically for recycling, perhaps even with a shorter life or some kind of, plan for routine replacement of PV panels.
I am not aware of PV manufacturers designing for recycling that has the side effect of reducing lifetime. I think that the industry wants to maintain, and in fact, Department of Energy has put forward a goal that they want to elongate or increase the lifetime of PV modules, i.e. to make them even more durable, as one way to try to reduce the overall levelized cost of electricity from PV, which considers then that total lifetime of energy production. However, I won't name the manufacturer, but manufacturers that have thought about recycling and even developed their own systems for recycling can include the recycling business unit as part of the approval process for a new design for their modules. So in other words, when a new design comes up and they want to improve efficiency, or they want to change the form factor, or they want to do some other change that can reduce the cost, I mean, all of these are motivations to perhaps change the designs. One consideration and one mandatory step in the process of changing that design is to ensure that the recyclability is still at least as good as before, and perhaps even enhanced through the process. So there is some example of where manufacturers are starting to think ahead, and I'm not sure exactly if it's designed for recycling, but at least that recycling is in the custody chain, if you will, for approval chain rather, for those next designs. I think design for recycling as a whole is a nascent area for the industry. And really because of that sort of natural tension between wanting the long lifetime and extreme durability versus the trying to move to a system that would be easier to dismantle, easier to disassemble, and then easier to recover materials from. But that tension, I think, is something that can be addressed with smart minds applied to the research development challenge.
Good, thanks. Another question here, do you see PV module recycling integrating with other e-waste recycling or developing new markets that incorporate batteries, inverters, and other balance of system components for recycling?
Mm-hmm. Yeah, good question. There are several existing recyclers that are by dollar volume, and I'm sure mass volume, that's an oxymoron, but mass, e-waste recyclers first and foremost. that, similar to how I described how glass or metal recyclers, the ones who responded to our survey at least in Europe, treat PV modules as sort of a batch through their process. Probably not optimally designed for PV modules, I would say, but nevertheless have some features of similarity where they could put through the same process, and they have a largely similar, I guess, set of buyers of the sorted or recovered materials from the modules. So I think there is overlap with e-waste, and but also, as demonstrated in Europe, there's overlap with other waste management commodities, glass and metals. In the case of those ones that we surveyed in Europe. With regard to batteries, I'm not sure I see as much of a similarity for batteries. I'm not sure that there would be an integrated recycling system that could handle both PV and batteries, although people are certainly thinking about the deployment of PV and batteries together in an integrated way. I'm not sure that the waste management necessarily will be handled in the same system. It could be the same business, but two separate systems that address those. Inverters would be, another form of e-waste, and so has some more similarities, I think, with PV modules, and therefore, like we've seen examples of, some manufacturers that handle e-waste broadly could handle PV modules.
Great, thanks. We've got a couple of questions about, you mentioned in your presentation the recycler in Italy that's recycling PV modules, but there not being sufficient supply. Do you know when there will be enough product for recycling at the Italy facility, or when it's apt to start again?
No, I mean, I am not representing their facility, and I don't know their business plan, and I don't know specifically the status of PV waste generation in the country of Italy. So I can't answer that question specifically. I mean, I would say that in general, we can apply the same projection or the model that we use to develop that projection of waste going forward with updating it to today, and with some new information perhaps about failure modes and fraction of modules that fail for certain reasons, from those sort of engineering or kind of warranty reasons. So we could we can get to the country level, and I think probably if we were to apply this, we could get to the U.S. state level, because we do have projections for PV deployment at the U.S. state level. But we're information poor on one of the, and if you wouldn't mind flipping, I don't think I have control anymore, going backward one slide to the information gaps that I pointed out. These other failures are ones that we don't have very much information on at all. And information about the amount of PV modules that will become waste and need waste management, such as recycling, is, I think, pretty important for this business to get off the ground, because one needs to understand well what your supply is for you to feel like you can confidently make investment. So this is where I hope that some states perhaps will lead, and possibly other jurisdictions, whether smaller sub-states or perhaps national, could try to fill some of this information gaps and help to enable this industry.
Great, thanks. Yeah. Do you know if
actually, if you don't go through these slides?
Yeah, sorry. There we are. A couple questions on about the cost of recycling solar panels, the average cost, or how that might compare to landfilling of modules.
I know of no public information source for that, unfortunately. I would be interested in trying to develop such information because I think it will be useful for many people. Anecdotally, we have heard of costs in the range of 10 to 20 or more dollars per module to recycle them, a cost that the owner would have to pay the waste management firm. But that should be taken with a grain of salt because it's not a comprehensive survey and it's not sort of documented. But that's just anecdotally. Landfilling, I think, is quite a bit less, but also quite variable because tipping fees at landfills, is quite variable across the U.S. So I'm not going to sort of venture a quantitative guess on that because I think that's going to depend a lot on the state and the jurisdiction and what you all as state level stakeholders would know far better than I would. Of course, there's a question of legality of that as well. So, that of course needs to be considered.
Great, thanks. Can you talk about the energy intensity of various recycling methods?
Sure. If you give me control again, I can go backwards or direct you to go backward.
Okay, yeah, handing you over control right now.
Okay. Oh.
You may have to
here?
Scroll back a little ways.
Okay, whoops, I went too far. There. Oh, perfect. This is the one. 50 to 100 kilowatt hours per ton of module input is the range, or typical range, I should say, of the 5 recyclers that responded to our survey. And note that 4 of them are doing these as batch runs, which means that they haven't individually metered their process just for that batch. So it's taking a pretty high level scaling, I guess, of their total energy use and applying it to this batch. One facility, the 5th respondent, was the one that was, developed a system that was a dedicated PV recycler. And so the energy use for that system was a little more specific just to PV. And more information can be found in the report, for which the citation is listed at the bottom of this slide.
Great, thanks. A question about whether, other than Washington, if there's other states that you're aware of that are developing legislative mandates around this.
Well, I think that states are pursuing, or some states rather, are pursuing legislative approaches, and other states are pursuing regulatory approaches. And I think at least in one state, if not more than one, have pursued, in essence, a combination of those. And I think somewhat independently. So, I mean, there was a bill introduced in New York State. I think that the session has ended and that bill did not pass, so it would have to be reintroduced. I believe there's a regulatory process going on in a couple of other states in the upper Midwest. Those are the ones that come most prominently to mind. Perhaps someone could write in a comment and name their own state if they choose to about processes going on. I think suffice to say that there's at least a handful of states that seem to be maybe somewhat active in looking at this, and I would imagine some other states that are, pretty eagerly observing what's going on, and may perhaps even in this coming either legislative session or regulatory year, think about initiating a process.
Great, thanks, Garvin. A Here's a question about when you expect the first major wave of utility scale PV retirements to occur in the U.S. In other words, when is this issue really gonna come to a head in a big way from a time perspective?
Well, like we kind of reviewed before, there are a few different modes or pathways, I guess, that produce the waste. And one happens early on, that's the manufacturing off-specification waste. So that occurs during the time that deployment, or the manufacturing is occurring in advance of deployment. And deployment projections are very high. We've had significant growth in PV deployment. And just to remind about those sort of back of the envelope figures, we have about 7 million pounds of solar panels being installed in the US every single day. And so some of that before installation is manufacturing off spec. Some of it is going to be warranty issues, which occurs usually early. So within the first few years of what's anticipated to be a 20 to 30 year lifetime of a module in a facility. And then other waste is coming really at the end of life. So it can happen anytime. We're already seeing cases where large utility scale fields, so outdoor, typically ground mounted utility scale fields, might be exposed to a large hail event or a high wind, perhaps hurricane event, or even a lightning strike that can occur, that can affect many, many panels at the same time. And now we have a lot of panels coming offline at once that are typically waste. So they have to be addressed somewhat more immediately. The larger wave will occur probably from more like the anticipated end of life, the 25 to 30 year warranty period at the end of that. And for that wave, 2020 would be kind of the early part of it, because we had growing installation starting in the 90s, but really picking up in the 2000s and now in this decade, 2010s. And so it's probably that wave starting in the 2020 timeframe, but extending through 2030 and beyond. And the figures from the report that I highlighted in the beginning, the IEA IRENA report that was published in 2016, provides some of that sort of data for the U.S. as a whole about when we might be expecting these panels. Although at the time that we did that report, we and still don't have very much information about, especially the kind of weather events and other damages that can occur in the field outside of warranty issues.
Great, thanks. We have a question about relating to your slide on silver, and if you can elaborate on what compounds are being used to replace silver. And I'll pass you back screen control in case you want to go back to that slide.
Okay. So copper is one element that's being looked at as a replacement for silver. Also, just simply smarter manufacturing techniques that are more precise as to the just absolute minimum amount of silver that's required. So it's and I call this dematerialization. So some of it is substitution, but I think most of this trend is driven by dematerialization, just using less.
Great, thanks. And we are very close to the hour mark, and I do just want to give you a chance before we sign off here to, if you have any last words or parting thoughts on this issue in general.
Thank you for the opportunity for that. I mean, I see this as an example of a real opportunity that, if we can start to develop the knowledge, and that would come from R&D as well as some industrial experience, but also the supporting policy and sort of regulatory infrastructure, if you will, to take a technology that's a clean energy technology, known as that, has a strong reputation in that, and really is that, and that's based on research that I've done and many, many, many others, and build in a circular economy where we can ensure that the continued and I think increased deployment of this technology fulfills that sustainability promise. And there are challenges to from where we are today, but those challenges are surmountable. I am totally confident. And with the right structures in place and with enough effort in the research and industrial experience, I think we will get to a point where we can have a circular economy for PV modules that is at a reasonable cost and provides the kind of environmental benefit that we want to see from the management of this clean energy technology.
Great. Thanks so much, Garvin. Thanks for your great presentation. And I'm sorry we couldn't get to all the questions today, but I do want to thank our audience for tuning in and for all the good questions you did ask. My email address is on this screen if you want to follow up with questions to me. And lastly, before signing off, I want to tell you about one more solar-related upcoming webinar we'll be hosting on Thursday, August 30th from 1 to 2 p.m. Eastern Time. We'll host a webinar on community solar program design and implementation for low and moderate income customers. It'll feature other guest speakers from NREL who will talk about a report that they authored, which reviews existing and emerging low and moderate income community solar programs and discusses some other elements as well. So with that, again, just want to reiterate my thanks to you, Garvin, for your great presentation and your great answers today, and we'll see you next time. Thank you.